This begins with the problem that we've seen before. Find the equation of the tangent line if we have a parallel line. So if I know that the tangent line needs to be parallel to this line, I can take that, solve it for y, and determine that the slope of the tangent line should be equal to -3. If I want the slope of the tangent line to be equal to -3, then let's take the first derivative of the curve, y prime is equal to 6x plus 3, and set that equal to the slope that I want. I should get that I'd have an x value of -1. Knowing that I have an x value of -1, now the trick is to figure out at x equals -1, what would the tangent line be? Well, I now need to figure out what y of -1 is. I need to find the y value at -1. So that would be 3 times plus -3. That'd be 0. So my ordered pair is -1, 0. And my slope is -3. So just put it in point slope form. Y minus y1 to be 0 is equal to -3, x minus -1. And I get y is equal to -3x minus 3. Number 2, we have perpendicular. Equation of the tangent line. If the tangent line is perpendicular to the line x minus 9y is equal to 2. If I want a perpendicular line, take this and solve it for y. So I get 1/9 x minus 2/9. And I know that the slope of that line is 1/9, but the slope that I want, the perpendicular slope, is the opposite reciprocal of 1/9, which is -9. So given that, let's go back to the original. I have the curve y is equal to 2x plus 1 over x. And if I rewrite that, I get y is equal to 2 plus x to the -1. That's just easier to take the derivative because I don't have to use quotient rule. Y prime is equal to -x to the -2, or -1 over x squared. So I want to set that equal to -9. And I would get x squared is equal to 1/9, or x would be equal to the plus or minus 1/3, not 3. So we're going to have two possibilities. One is to say at x equals 1/3, and I want to figure out what y is. Well, I'm going to just kind of plug it into this one right here. X 1/3, y is equal to 2 plus the reciprocal of 1/3, or 2 plus 3, or 5. And so I get y minus 5 is equal to 1/3 x minus a -9, or y is equal to 1/3 x. That'd be plus 8. Yeah. So that's one possibility. And then the other one is that at x equals -1/3, we get y is equal to 2 minus 3, or -1. So I'd have y minus -1 is equal to 1/3 x. Oops, I completely messed that up. I get y minus 5 is equal to -9 x minus 1/3, which would be y minus 5 is equal to -9x plus 3, or y equals -9x plus 8. Then at x equals -3, y equals 2 minus 3, or -1. So you get y minus a -1 is equal to -9 x minus -1/3, or y equals -9x. See, that'd be minus 4. So there's your two possibilities. Number 3, a normal line is defined as a line that is perpendicular to a tangent line, but passes through the same tangent point. So the equation of the normal line to the curve, if the normal line is parallel to the line x plus 9y is equal to 2. Well, if the normal line is parallel to x plus 9y equals 2, I'm going to take that and solve it for y. I get negative 1/9 x plus 2. So I want my normal line, or I'll say normal line slope, is negative 1/9, which means that my tangent line slope has to be perpendicular to that, positive 9. So let's take the curve, y prime is equal to 3x squared minus 6x, set that equal to 9, and figure out at what x point or points would that be true. Could take out a 3, factor it, and we get x equals 3 or x equals negative 1. Giving myself some more space here. Oops. I'll pause it. We have these two possibilities again. At x equals 3, y is equal to, that'd be 27 minus 27, so that'd be 0. Just plugging it back into the original curve. And the slope, we want the normal line slope of negative 1/9, so we get y minus 0 is equal to negative 1/9 x minus 3, or y equals negative 1/9 x plus 1/3. Then at x equals negative 1, y equals negative 1 minus 3, or negative 4. So I get y minus negative 4 is equal to negative 1/9 x minus negative 1, or that would be y is equal to negative 1/9 x. See, minus 1/9 minus 4, or y equals negative 1/9 x minus 37/9. Circle the other one. Okay, moving on to the back, we've got tangent lines to the curves that go through this point 0, 4. Now this is a new kind of problem. This is one where I can't just look at the graph and say I know exactly what those points are, even though I probably do for this curve. What I want to do is I want to figure out, only knowing this other point, or basically picking any point, being able to figure out what the tangent lines that would pass through that point would be. So I want the equations of these two tangent lines. There's a very tricky, but good, well not tricky, but very neat way to solve this. I know that if I wanted to find the slope through algebra, given this, and I treated this as an ordered pair, x comma x squared, then my slope with algebra would just be the change in y over the change in x, which I can write as the change in y would be x squared minus negative 4 over x minus 0. Furthermore, if I wanted to find the slope with calculus, I know that we just do dy dx, the first derivative, which would just be 2x. Well, these two slopes should be equal. X squared plus 4 over x equals 2x. Do a cross product, x squared plus 4 is equal to 2x squared. Set it equal to 0, and I get x squared minus 4, which means that x has to be equal to plus or minus 2. So then we just kind of go through and say at x equals 2, I would know that y would be 4, and the slope, if I plug 2 into here, the slope should be 4 as well. So y minus 4 is equal to 4 times x minus 2, or y equals 4x. This would be minus 8 plus 4, so minus 4. And that works. Then we do the other possibility at x equals negative 2. Y equals, plugging it back into the original, y would be 4 as well. And slope would be negative 4. So y minus 4 is equal to negative 4 x plus 2. And I get y is equal to negative 4x minus 4. And if I look at the original curve, those lines do match what I'm seeing, so that works. Okay, last one, this is similar. Lines tangent to this curve that pass through the point 2, 0. So now it's not so easy to see or predict, but I have one here and one here that I should be able to find. So we're going to do the same thing, slope with algebra. If I treat this as the ordered pair, x comma x cubed plus 3x squared, and I just do my change in y over change in x, I'm going to get x cubed plus 3x squared over, that would be x minus 2. Then my slope with calculus would be to do a derivative, 3x squared plus 6x, set them equal to each other, x cubed plus 3x squared over x minus 2 equals 3x squared plus 6x. I'm going to have to do a cross product, so 3x squared plus 3x, or x cubed plus 3x squared is equal to, that would be first 3x cubed plus 6x squared minus 6x squared, so the middle term would drop out, then minus 12x. Set it equal to 0, I get 2x cubed minus 15, oh sorry, not minus 15, 2x cubed minus 3x squared minus 12x. Factoring that out, I get x times 2x squared minus 3x minus 12. That can't factor any further. So what I have to do is just do the quadratic formula if I want to. X equals opposite of 3 plus or minus the square root of 9 minus 4 times 2 times negative 12 all over 2 times 4, or 2 times 2. So I get x is equal to 3 plus or minus the square root of 108 over 4. Let's see, is that right? 96. Hang on, I don't think that's right. Nope, that's 105. So that can't simplify. 5 and 21, no. So that's done. And that actually answers our question. It wanted the x coordinates of the point of tangency. So I've got those two, and I still have from right here, x is also equal to 0. So this would be my solution. And if I look at the problem, I should find 3 points of tangency now. And I do see them. I didn't see that before. But there's one, here's one right here, and here's one. And they all pass through this ordered pair to 0 that we wanted. So that's it.